Okay, so first of all, make sure you get, if I give you one of those on this problem, make sure you get two of those problems right. Because again, it all counts. If you're given that the cotangent is 7/25, then you know for a fact that the tangent is what? 25/7. So that's automatically two questions that are right. Now, if something isn't reduced, make sure you reduce it. To get sine, cosine, get these, and then flip over the answers to get those. For sine and cosine, remember, sine is adjacent over the hypotenuse, and cosine, I just messed it up, opposite over the hypotenuse, and this is the adjacent over the hypotenuse. Draw a picture if it's not clear to you. And honestly, cotangent messes with my head. It really does. You know, I really enjoy Cho Chang Kao. I think he's a really good person. But SOHCAHTOA and I go a lot farther back. Tangent, opposite over adjacent. So since I know that tangent is 25/7, tangent theta, 25/7, draw a right triangle that's got a theta in it. So opposite of that is 25, and adjacent is the 7. And then your hypotenuse, whatever you choose to call it, I'm going to call this Z, 7 squared plus 25 squared is equal to Z squared. So 49 plus 625 is equal to Z squared. This adds up to 674, all right? Equals Z squared. And then we can take the square root. Z is equal to, that will be 28. Is that right? That's not right, is it? No, it's not right. Not 28. Did I really mess this up? I meant to give you a nice one too. I really did. I believe on the quiz I'll give you a nice one. Did not mean for that to happen. Okay, so you cannot have decimals. So on your test, because this won't happen on your test, and it's not going to be so nice. I really meant to give you the bad answer. What I think I did is I messed up the placement. I'll give you a hint. On your quiz, it should come out nicely. Keep that in mind. And I don't know if you guys have actually taken the time. And I'm not saying you should memorize Pythagorean triples, but they are good friends when you have them. Triples, triples, triples. There you go. 7.425. That's what I'm gonna do. So I put the 25 in the wrong place. That's it. I just have to check the machine. We got to simplify. So square root 674. We know we can divide by 2. So that's 2 times 337. Yes. 337. Well, let's see. It's not divisible by 2 anymore, but 3 plus 3 is 6. 6 plus 7. That's not divisible by 3. You can't divide by, that's it. 337, not going to divide anymore. No perfect squares. 674 is not going to come out of the square root. Nothing's going to reduce. So this is the square root of 674. So therefore, the sign is 25 over that square root of 674. And the cosine is the adjacent, 7 over the square root of 674. The cosecant is reciprocal, square root 674 over the 25, square root 674 over the 7. If you choose to rationalize, that's up to you, but it would be 25 square root 674 over 674, and this would be 7 square root 674 over 674. When you think about it, which one looks more simple? The first ones. They're actually easier to flip over too. Okay. Any questions? Apologize that took so. It shouldn't take that. Then, this is going to get you, and I want to pull this up and show you. And I'll do this quite often. This is a copy of your text. The questions removed. Okay, and it always can be changed. Question like, find the complement of an angle whose measure is. I give you an angle, what's the complement? Convert the angle to. I'll give you radians, you got to convert it to degrees, or you degrees convert to radians, which means this one would be the other one. Convert degrees into radians, or convert to, and then over here, convert radians to degrees, or vice versa. Okay. This stuff we haven't, or we did talk about coterminal. We haven't done a reference angle yet. Identify the quadrant. We haven't done this yet. But here you go. Okay. Find the sine, cosine, tan, all 6 for a angle whose side passes through a given point. That's going to happen with respect to today. Find the exact value of an angle, or find the exact value of the 6 trig functions given that. And we haven't really talked about what happens when theta terminates in one of the other quadrants. Find the exact value, no decimals, for the trigonometric value for the given angle. Things that you're supposed to know from the unit circle. So lots of exact values. And then you have use a calculator to find the decimal approximation, just like we're doing right here. What's going to get you is, do you know what you're given? That is the cosecant of just a 3. A 3 what? It's radians. There's no degree symbol. There's no degree symbol. So 3 radians. 3 radians. So that means your calculator needs to be in radian mode. And you've always got to be, you must stay vigilant. Because I've always heard students say, my calculator told me, Not grading your calculator, I'm grading the person putting stuff into the calculator. So there is no cosecant button. There's no secant. There's no cotangent button. All you have are sine, cosine, and tangent. Remember what I told you? The negative ones don't mean cosecant, secant, or cotangent. Those are the inverse trig functions. They give you the inverse of a ratio and tell you what the angle is. First thing, make sure you are in radian mode. So you go to mode, and right now my calculator is in degrees. So I got to go down to where it says radians. And it's blinking on radians, but degrees is highlighted, so I hit enter. Now it's blinking on radians, and radians is highlighted. If you only click on, and let me move it over. If I only move it over to radians and let it blink on radians but never hit enter, and then I go, oh, I'll just go back because I moved it over to radians. If you don't hit enter, it's not going to switch it. You gotta hit enter. And then back to my screen. And like I said, there's no cosecant button. But you know the identity. You know that cosecant theta is 1 over the sine of theta, and vice versa. You know the sine of theta is 1 over cosecant theta. You can interchange them for each other. So if the only button you can press is sine, then the only way you can take the cosecant of 3 radians is to go 1 divided by the sine of 3 radians. And you can punch all that in at once, 1, hit divide, and then punch in sine, but make sure you have parentheses as necessary. I prefer to go a little bit at a time because students usually, why can't I make it through? Students usually go, where did that come from? So 1 over, and I hit sine. And then 3. And sine of 3 is 0.141120081. Now, if you don't write all the digits, that's not necessarily bad, but it's nice to see that you are paying attention and keeping track of what you're doing. It's up to you. But what you don't want to do is when you go to the next step, round before you put it in. If you round right now, you're not going to get an accurate 6 decimal count. You want to use as many decimals as you can as you calculate your answer and then round at the end. So now I'm just going to hit 1, and then I'm going to hit divide. And I don't have to type in the answer. I can just go second and click on the negative sign, which is going to give me the answer in the denominator. So it's 1, and I'm sorry you can't see that. 1 divided by the last answer that was in the calculator. And then that would be 1 divided by that, 0.14. And so the cosecant of 3 radians is 7.086167396. On your quiz, down at the bottom of the box, your final answer, that's where it's going to go. There's 6 decimal places, 1, 2, 3, 4, 5, 6. That's where the 7 is. The 3, does it round 7 up or leave it at 7? Leave it at 7. So 7.086167. If I am in degrees instead of radians, Just so you see the difference. No, back to these. Then sine of 3. And enter. So the sine of 3 radians is approximately 0.14, and the sine of 3 degrees is 0.05. Not the same. It's the easiest question that people get wrong because they're not paying attention to the mode of the calculator. Okay. Calculator is always right. It's what the input is. Okay, any questions about this? Again, this is going to be open, no quiz, so you can have this out when you do your quiz. Or anything else you want to have. Right. One. And I'm going to post. I'm going to post for you guys. This, and all it is a page out of the book. This right here, I'm going to post this page as just a single page, and I believe it is just this. I know you guys hate this, I'm sorry. I open everything up and then I close one PDF that has 4 tabs in it, and then I lose everything that I had opened up. Yeah. This right, okay. I'm going to post this where you have the complement identities. The sine of the complement is the same as the cosine of the original angle. So in a right triangle, one angle's adjacent is the other angles, or the complement angles opposite. If this is theta, then up here is 90 degrees minus the theta. So the sine of 90 minus theta, opposite over hypotenuse, opposite is theta's adjacent. So it would be the cosine. It would be cosine of angle theta. And the cosine adjacent over hypotenuse for 90 minus theta, well, that's theta's opposite. So that's opposite over hypotenuse. So that's the sine of theta. Same thing goes with tangent. And then you flip over You flip over cosine and you get secant versus cosecant, and you flip over sine, you get cosecant and secant. So I have this page set aside and I'll post it. Reciprocal identities. Okay. And then not to mention at the bottom, tangent, Pythagorean identities, and then these guys right here, even and odd trig functions. And that's going to come up as well. Okay. This is just a short list. By the end of the semester, this is what the list looks like. Of stuff you should know. But that's later. You just try to squeeze a little bit into your brain at a time. And it's not a matter of memorizing. It's a matter if you use it, you start to know it. You didn't memorize how to tie your shoes, you started doing it. You started tying your shoes, and then you kept repeating it, and you know how to tie your shoes. You don't have your phone number memorized, you know your phone number, you know your address. Repetition. If something's important to you, you take the time and you know it. We left out 51, so skip 53, 55. Just looking at 55 right here. What is A? You should be able to do A in 3 seconds. One-third. What is B? What's part B? 4/3 square root 2. Because you're given cosecant is 3, so the reciprocal sine would be the reciprocal of that, 1/3. And if you want cosine and you're given secant, well, then cosine would be the reciprocal of the secant. And that technically does reduce kind of nicely, 4/3 square root 2. This time, if you multiply by root 2 over root 2, you get 4 square root 2 over 3 times 2. 2 goes into that 4 2 times. So this is 2 square root 2 over 3. Okay. But again, I don't expect you to rationalize it, so you can stop right at this. But when you look in the back of the book, it's going to look like that. You're going to go, what did I do wrong? Well, he didn't do anything wrong. Tangent, you can just put sine over cosine. Sine over cosine, so that would be 1/3 over 4/3 square root 2. Now, a fraction divided by a fraction. 1/3 divided by 4/3 square root 2 means 1/3 times 3 square root 2 over 4. The 3's reduce, you just have square root 2 over 4. And there's your tangent. Any questions? And then for secant, the complementary angles go together. So the sine of a theta is the cosine of the complement, 90 minus theta. The cosine of a theta is the sine of the complement. The secant would match up with the cosecant of the complement, and the secant would match up with the cosecant of the theta. Or if you just turn to the page that has the identities on it, there you go. And cosecant theta is just 3. It's not about figuring those things out. You're actually given everything you need. You just got to put the pieces together correctly. You have to interpret what you have because you know what they mean. You know what they mean. It's language. You're going to start speaking it, which means I need you for your sake. You need to talk back to me, ask questions, speak it out loud. You know, sometimes I'm the only person, not the only, but a lot of times it's a room of quiet. And I don't like that. I'm teaching face-to-face because I want interaction. Not, you know, I don't even care if it's a debate. I love it when students challenge me. Why is it that? Explain. But that just means that, you know, if you're getting it, that's great. But even if you're getting it, you know, I don't care if you shout out the answer. It means you're engaged. It means you're going to understand a little bit more. Don't be passive. Your future's on the line. My future's on the line because I need you guys to, you know, really good. Remember, I'm going down with that. 5. Oh, I know what it is. I use 51, so you guys would be 49. That's what it is. You guys got to be 43, same. 59 to 80. Use trig identities to transform one side of the equation to the other. Okay, this is where the proofs begin. Now, you're not going to, this test does not have proofs on it. When we do proofs, you'll know. You have to make one side become the other side. In geometry, you have a given and you have a proof. And you go from the given statement and you use geometric definitions, theorems, postulates to create, you know, properties of algebra to transform the left side statement with a reason, and side by side you go all the way down. In trigonometry, it's a little more algebraic. You just use substitution. You use identities. What else is it? And that's the kind of the idea that it is. It's just a matter of what else is it. It's like trying to cross the road. When you do an identity, you have to go from the left side to the right side, or you can go from the right side to the left side. It doesn't matter. But you got to get there following logical steps, making basically correct substitutions. Tangent theta, cotangent theta is supposed to equal a 1. And you'll find out why they give this condition. 0 is less than theta, which is less than pi over 2. So that means you can plug any angle you want in radians. That has to be bigger than 0, so you can't plug in 0 radians, and smaller than pi over 2, so it's got to be smaller than pi over 2. So it's in the first quadrant, but it can't be at 0, and it cannot equal 90 degrees or pi over 2 radians. So it can't be on the x or the y axis, just in between, for a reason. You don't need to know it yet, but we will cover that. When we do an identity proof like this, you just have to say, okay, which side is the most complicated? That's the side you want to work on. Which side can you do the most damage with? Well, you have something over here that can't equal other things. 1 is kind of hard. 1 can equal a whole bunch of stuff, but it's a little more simpler for a fewer things over here. 1's not, I mean, you can do all sorts of things with 1, but really, which one are you going to pick? Over here, you can do a few things and you have very limited choices. So the better thing is to start over here. in addition to this, you don't get to work on both sides. In other words, if you're walking across the street from one end of the street to the other, you go from here to some point over here, and you have to walk across the street. The street doesn't get to meet you in the middle. You have to get all the way across. You only get to work on one side. So you either make the left side become the right, or you make the right side become the left. You just got to pick a side to work on. One side only. So I'm going to work on the left side, and I'm going to make it become the right side. And as you do this, make sure you write down the whole thing all the way down. In other words, don't, like a typewriter, go left and right, left and right, left and right. Just the next step should be here, not going that way. Tangent theta times cotangent theta equals 1. Well, what else can think? Tangent theta and cotangent theta are reciprocals of each other. You are told in the identities that tangent theta and cotangent theta are reciprocals. This is the reciprocal of tangent theta. Now, if I want to just be really clear about what I'm doing, tangent theta times 1 over tangent is tangent theta divided by tangent theta. And so we get 1 equals 1. I mean, that's a real, hey, here's one with training wheels to start with. But there's lots of ways to cross a street. You also know that tangent theta times cotangent theta equals 1. You also could have used, hey, this, I know this is sine theta over cosine theta. And one of the other identities says that this is cosine theta over sine theta. So this would be sine theta cosine theta over cosine theta times sine theta. So sine over sine reduces, cosine over 1 over 1 equals 1 equals 1. And I'm showing a lot more steps than you probably would need. But you could go that way. I could have changed this into 1 over cotangent times cotangent. Cotangent over cotangent equals 1. When I grade this part, when we take this test, it's like grading an essay. So the way you might go is completely different than the way you might go, which way. So I write the way I would go, and I do the problem from both sides. I do it from left side, make it the right side, make it the left side. And then if somebody does it a different way, all I care about is, like reading an essay, did every step logically come from the previous step? Now you get to play a little guessing game. Every one of these questions, when we get to it, comes with an extra chance at a bonus point. In mathematics, when we finish a proof, it's like finishing a story. You need to say the end. In mathematics, when you say you're finished with a proof, the classic way of finishing a proof is QED. Qualis erat demonstrandum. Latin for we have demonstrated the quantities that we needed to prove. Okay. Qualis erat to QED. Now I knew about that until I got to UCLA, my freshman year. Professor Raymond Radheffer, my calculus teacher, he would finish his proofs with, oops, over here, down here at the bottom, W to the fifth. And that was his unique way of telling everybody he's done with the proof, and W to the fifth stands for, which was what we wanted. So ever since I've been teaching, I tell my students, okay, when we do proofs, finish it with a QED or a W to the fifth. I have on my answer key, either a key, just one of them, a QED or whatever. If you can put exactly what I have, it's an extra credit point. If you don't put anything, it doesn't matter, it's extra points, it doesn't matter if you put it or not. If you put both of them, I'm taking off 10 points, because you can't cheat like that. But if you don't match it, it doesn't hurt you. If you do match it, +1. Okay, don't put anything, doesn't matter. So when we do proofs, only when we do identities, when we do proofs. Because once I say this, people start putting these things on every single problem. No, just proofs. Okay. So 59, we're doing odds, so pick one. What do you want to see? Any one of those. 65. Remember, one of the reasons why I went to such big efforts and trouble to provide you with this is to remind you how important some of these things are. So 65, we are supposed to transform secant minus cosine over secant. Secant theta minus cosine theta over secant theta, and make that equal sine squared theta. Okay. Now, I'm just going to go the easiest way possible. On the right-hand side is sine squared. Sine squared from the identities. There's only 3 of them, but remember they can be manipulated. Sine squared could be 1 minus cosine squared. Sine squared is the same as 1 minus cosine. And that's, you can use that as a given. This and any of the Pythagorean identities that come straight from the Pythagorean identity. So you have your sine squared theta plus cosine squared theta equals 1. And then if you divide everybody by cosine squared, you get tangent squared theta plus 1 equals secant squared theta. If you divide everybody by sine squared, you get 1 plus cotangent squared theta equals cosecant squared theta. But it's like, you know, a late night infomercial, that's not all. This, you can also get sine squared theta is 1 minus cosine squared theta. You can also get cosine squared theta is equal to 1 minus sine squared theta. Any derivation from this one right here, Big Daddy theorem, you don't need to like prove as you do the problem. You can just make the substitution. It's an identity. It means that it already has been established that these things are true. So secant squared minus 1 is tangent squared. Cosecant squared minus cotangent squared is 1. You manipulate it any way you want. Over there, no fraction. Over here, I got a fraction. One of the easiest ways to get from A to B is to get rid of my fraction. What I'm going to do is I'm going to split my fraction. One of the things about arithmetic is when you add or subtract fractions from each other, whether it's A plus or minus of B over a common denominator of C, that means you had A over C and you were adding or subtracting B over C. You had a common denominator and then you added or subtracted the numerators above it. Right here, you're subtracting these two over secant, so that means it was secant theta over secant theta minus cosine theta over secant theta. So I just split and separated that fraction into two separate fractions. And that's just an arithmetic / algebra move. And then every single time you bring this down, sine squared theta. Okay. One of the things about walking across the street, as you walk across the street, don't close your eyes as you walk across the street. You may never get across the street. Or when you start walking across the street and you pick a point that you want to walk to, and then you close your eyes, you're going to start veering off over here. Guess what? You're not going to hit the point you're aiming for. When you don't continually write down the spot that you're aiming for, you're going to forget what you were aiming for. And you wind up all over the place. And it's also called good discipline. Mathematicians have to be disciplined. If you're going to be a mathematician, you're going to be a computer engineer, you're going to be a doctor, you're going to be an accountant, you're going to be an architect, you're going to be a mathematician, you're going to be a statistician, you're going to be whatever you're going to be. I really want my doctor to be disciplined. I want my accountant to be disciplined. I want my, I want my baseball statistician to be disciplined. Okay. Think about where you're going. Now, if you could, you might go, oh, over here, that's 1 minus cosine squared, but you cannot work on both sides. You can't do that. But that doesn't mean you can't think about what the other side could look like. What else over here? That's 1 minus cosine squared. Well, where am I aiming? Well, look what I got. I got 1 minus, this is cosine theta over secant, which is 1 over cosine theta. Which means this is 1 minus cosine theta times, when you divide by 1 over cosine, you're multiplying by the reciprocal, right? Times cosine theta. So this would now be 1 minus cosine squared theta Now, some people, and this is the bad part, they go, oh yeah, that's right. That's what sine squared can equal. And they stop. You're not done until you actually make the left equal the right. You have to have equal, same thing on it. So now this, there's my sine squared theta equals my sine squared theta, and you put your finishing touch to that. Okay. For some of you, it might be really frustrating when you're doing these things. It might, until eventually when you get them, when you get it, it's like, oh my God, these are the best things ever. And one of the things that prevent people from getting the proofs, the identity proofs, is I don't know where to start. If you're trying to walk across the street, you need to just take a step. You can't get across the street without actually moving, without just doing something. Because eventually one step will actually lead to a second step. And then, you know what? Sometimes you're completely not even in the ballpark. At least you know which way not to go. Now you try something different. But you don't train yourself at these things until you practice. I'm gonna be nerdly honest with you. This, the proofs right here, favorite part of Trig. No solving involved, no graphing involved. It's just what else are they? What else could it be? And I'm sorry, but I know I use this way too often, but they are math. It's a puzzle. You're putting the pieces together to make the right side equal the left side, or you can work the left to make the right. This isn't the chapter that we do the proofs in, but it will give us that. It's a start. All right. We did our special triangles. I don't know why the glasses are not staying right down the nose. But sometimes the math is perfectly fine, and then other times it just doesn't. Now they want to know, without a calculator, they tell you what the sine or cosine equals, what the state. So you can do, by heart, you should be close to it. Cosine of 45, square root of 2, 1 over square root of 2, whichever you pick. Because you know your 30, 60, 90, 45, 45. But what if you're told the answer, so you now need the question? Jeopardy time. And like I told you last week, I only actually know one of them, and that would be sine of 30 is 1/2. Now the 45, that's a different animal because it's isosceles. Isosceles 45, it's using two congruent sides, two congruent angles. That's the one that uses the square root of 2. But the 30 and the 60, that uses the square root of 3. One of them is square root 3 over 2, the other one is 1/2. So here we go. I got a little something. I got to turn off the recording though, because I don't want